Okay, so in today's video we're going to have a look at the trigonometric graphs. Now, some of these graphs are quite tricky to recognise if you haven't already seen them, or if you've sort of not had a nice logical approach to looking at these. So hopefully this is going to help along with actually figuring out how to figure out some of these trigonometric graph questions, which can be proven, or have been proven to be quite tricky on some of the exams. So we're going to have a look at actually answering questions like this one on the screen towards the end of the video, but we're going to start off by actually having a look at how to draw these trigonometric graphs and how to recognise them first. So let's have a look at our first question that we're going to have a look at. Okay, so we're going to start off by having a look at actually drawing these graphs and a little logical approach to how we go about that. So I'm going to link the worksheet for this in the description, so feel free to download that and have a look. But we're going to discuss some of the methods for actually going about answering these questions. So we're going to kickstart with this question. So otherwise, grab a piece of paper, grab a pen, make some notes, and we're going to have a look at drawing the sine graph to start with. So this question says, on the grid, draw the graph of y equals sine x for 0 to 360. Okay, so we're going to have a look at actually working these out. Now, one thing I'm not going to do is I'm not going to discuss the ins and outs behind the graph and a lot of the sort of mathematics behind it. I am literally just going to discuss how you go about answering these questions and some approaches behind them. Okay, but one video that would be good to check out, which is going to be in the description, is the exact trigonometric values. That can help a little bit with understanding where we get these values from as well. But let's have a look at how we go about this question. Now, I'm going to do all of these on a calculator. Okay, so for this graph here, all I'm going to do is I'm going to have a look at the x values. I'm going to plug them into my little formula. So just like when we're drawing normal line equations, it says here to get y, we do sine x. So let's pick an x value. Let's start with 0. So if I type in sine 0 on my calculator, I get the value of 0. So I'm going to plot that as a coordinate. So that's 0, 0, and that is going to go there. Then I'm just going to move along the x-axis. So I'm going to do 30, and then I'm going to do 60, 90, 120. I'm going to go all the way up to 360. I'm going to try and do them as quickly as I can. So I'm just on my calculator now. I'm just typing in sine 30, obviously inside the bracket there, and I get a half. So I'm going to plot that as best as I can. It's quite nice on this graph here, and that's 0. Going back in, we get sine 60. Okay, and that gives us quite a nasty number there. We get root 3 over 2, obviously, which you might know from the exact values of trig if you check that video out. But as a decimal, when I convert that into a decimal there, it gets me 0.86. Now, I can't get that absolutely perfect, but I can get it near enough. I'm going to put it around here, 0.86, and I'm going to go back in and put sine 90 in. There we go, sine 90 gives us a value of 1. And there is our first little part of this curve that's going to go up there. Now, when I go for the next one, when I go for 120, if I go back in, I'll type in sine 120. There we go, I get 0.86. I actually get the same value as when I put in sine 60. There we go, and we'll discuss that a little bit more in a second. Okay, moving along, sine 150, that gives me a value of a half again. There we go, and then sine 180 gives me a value of 0. Right, so we've got like this sort of like hill-shaped little curve there. Kind of looks like a little wave at the moment, which you might recognise from some of your science graphs as well. So on to the next one here, putting in 210. Let's have a look. Let's put that in, 210, and we get negative a half. So that's negative a half just here. And then when I put the next one in, I get negative 0.86. There we go. So we're getting these same values as we got up there, but in the negative versions now. When we put 270 in, we get minus 1. And then we get the negative 0.86 again for 300. Again, we get a half for 330. I'm just typing in this last one here, 360. And there we go, we get 0 for that one. Right, I've typed those in quite quickly. Obviously, just take your time working through those with a calculator. And you will see we'll get these values here. And obviously, we want to just join that up with a nice smooth curve. There we go, and it makes this like almost like wave shape. There we go. And that's our sine graph there. So obviously, there's a few little bits along there that are worth discussing. One of those being some of the fact that we get these same values at different places. We actually get some sort of almost like a little reflection line within the curve. If I was to draw like a little reflection line up here, it's almost like a mirror image there on the other side of each part of the curve, just on that little sort of positive slope there. Obviously it changes as we get into the negative, but we could almost think of it like that. There's something worth noting with these values, the fact that the value of 30 there, sine 30, was the same as sine 150. Let's just draw that out. We've got sine 30 that equals a half, and you also had sine 150 that equaled a half as well. There we go. And if you have a look, these values or these angles here, as we start to look into the sort of trigonometry a little bit further, those two angles, 30 and 150, add up to 180. So these sort of supplementary angle pieces have the same values there, and that actually applies to any of these. If I was to look at sine 20 and sine 160, they both have the same value as well. Let's just type those in. Sine 20 gives us a value 0.34 with a few more decimals, and sine 160 also gives us that same value 0.34. So you feel free to have a little go with that and have a little play around with some of those values, but it's because we get this sort of mirror image on either side of the trigonometric graph there. Okay, but that is the sine graph. Another thing that you might note as well is that it does go through the origin, and I kind of always remember, and it's a little bit silly, but sin has that word in there, and I always kind of remember sin is in the origin. So it's just a little silly way of remembering it, but sin is in the origin. Can just help to determine or distinguish between the sine and the cosine graph. Okay, but sin is in the origin, and then we're going to have a look at the cosine graph now and actually go about drawing that as well. So let's have a look at that one. Okay, so for this one it says, on the grid, draw the graph of y equals cos x. And again, it's between 0 and 360. So we're just going to plug our values in on the calculator again. And we're going to do that for cos x. Now let's have a look. So cos 0 this time gives us a different value. We get 1. Okay, and this is obviously what distinguishes this one between the cos graph and the sine graph. This one is not in the origin. It starts at 1 there. And as we start putting values, you're going to see quite a similar pattern to the one we had before, but it's obviously just starting from 1 this time. So if we put cos 30 in, let's have a look. I put 2 brackets in by accident. So cos 30, we get this 0.86 value again that we got before. So 0.86, it's just there. And we put cos 60 in, and we get a half. Cos 90 gets us 0. And then it starts to dip below again. If I put cos 120 in, that now dips down to minus a half. Then we get minus 0.86. Then we get minus 1. Then we get minus 0.86 again, minus a half, 0, a half, 0.86. And cos 360 finishes on 1. There we go, so we get this same similar shaped curve, but it's obviously starting at 1, which has just sort of shifted that curve along a little bit. There we go, and that is our cosine graph there. Okay, but again, it's just plugging numbers into a calculator, plotting the points nice and carefully, and joining it up with a nice smooth curve. Okay, so don't be put off by these types of questions. Literally, it's just typing numbers into a calculator and plotting these coordinates. Obviously, on both of these graphs here, one other thing that you might have noticed is it always fluctuates between 1 and down here at minus 1. And that is also another key point here with our trigonometric graphs, is that it does fluctuate between 1 minus 1. But that is our sine and cosine graph, and now we're going to have a look at our tangent graph and see how that differs from these two, because there's not much similarity at all between these two and the tangent graph. It looks completely different, so let's have a look at that one now. Okay, so here we go. We're going to draw the graph of tan x, okay, between 0 and 360 again. And you're going to see this one's quite unique in terms of how it looks compared to the others. So to start with, I'm going to put tan 0 in on the calculator again. So just to confirm, on my calculator, I am literally just typing in tan 0 and pressing equals and getting my answer. And for that one there, I get 0. So tan 0 starts on 0. And I'm just going to put that coordinate on again. Now if we'll go for tan 30, I'm just going to move along the axes there, and we get 0.57. I'm going to try and plot that as best I can. Again, we are only doing a sketch here, so 0.57, somewhere around about there. It's not perfect. Let's go back in. Tan 60, and we get root 3. Let's convert that to a decimal. We get 1.73. So 1.73 is somewhere here. And then we'll go for tan 90. And our calculator says maths error. There we go. So I can't actually put tan 90 in. And obviously, if you've checked out that video on the exact values of trigonometry, you'll know that tan 90 is undefined. Again, I'm not going to discuss the ins and outs of why it's undefined, because you'll be able to have a look at that in the exact trigonometric values video, which is obviously in the description. But for that one there, we can't plot a coordinate. So I'm going to skip out 90. I'm going to go over to the 120. So tan 120. And that gives me negative 1.73. So for 90, it's down at negative 1.73, just there. Okay, so we're kind of thinking, hold on, how does this form a pattern? This is looking a bit strange at the moment. I've just plotted that in the wrong point, so it's definitely looking strange. That's under the 120. There we go. That's 120 there. Back in, let's change that for 150. Let's see where this is going. So minus 0.57. So that's going to be there. Then we've got 180 to put in, so tan 180, and that gives me the value of 0. There we go. On to 210. and that gives me positive 0.57, so we're starting to see a bit of a pattern here. We've got that 0.57 going in again, and then when we put the next one in, we get our value up here. There we go. So we're starting to see a bit of a pattern here. We've got an almost bit of a wave, and now we're moving on to the 270. So we put 270 in again, and again we get a maths error. There we go, so we're going to have to skip 270 out. Okay, we can't do 270, it matches what happens on the 90 there. So we're going to go over to the 300, so tan 300, and again I get negative 1.73, which is here. And on the next one, we get our minus 0.57, and on the next one, we get 0. Right, there we go. So that is our tan graph. It's a little bit odd, but when we actually join this up, we get a sort of wave here, we get a wave down here, and we get another wave there. And it's a little bit weird. There we go. If I was to actually draw lots of these out, you'd see that this line would continue down there, this line would continue up here, and we get this sort of pattern of waves that's sort of going along the x-axis there. But that is our tan graph. It looks a bit strange. It looks a lot different to the others. It sort of seems a bit counterintuitive when you do draw these on the, you know, if you were to do this on the calculator, because you have these sort of gaps from here to here, and you're kind of thinking, well, hold on, how do I join these up? But they don't join up at all. Okay, they're sort of just skipped out there because we have an undefined value of 90, so it all starts again. Okay, there is lots of mathematical language behind that, but to be honest, all we need to think about in this video is how we go about drawing it, how we would answer this question on an exam, and there we go, there it is, just plugging those numbers into a calculator and having a little bit of an understanding of what the graph actually looks like. So there we go, that is our sin, cos and tan graphs and how to draw them. Hopefully seems quite nice and simple, just plugging the numbers into the calculator and plotting them on the graph, and then actually just thinking about recognising them. So we had the sin graph, which was that nice wave fluctuating between 1 and -1 that started in the origin. We had the cos graph, which was pretty much exactly the same as the sin graph, but it just started on 1 and formed that nice little wave between 1 and -1 again. And then we've got our tan graph here, which is obviously quite different, but again, just a nice little method for actually drawing them and plotting this and just making sure we've got nice smooth curves. And obviously just making sure that you do have a nice smooth curve that goes through all the points, so not like my little rubbishy one that I've done here, where we've actually missed out a coordinate there. You'd want to have nice smooth curves going through all of those. But right, that is our 3 graphs, and we're going to use some of the ideas from these graphs to actually have a look at some of these quite nasty questions and see, just have a little talk about how we would sort of approach those in an exam. So let's have a look at our first one. Okay, so I've got 5 questions here. They're not in any particular order of difficulty. They're just some sort of different trigonometric questions where we're looking at these graphs and sort of thinking about how we would approach them. But feel free for any of these 5 questions to just pause the video. Obviously, if you've got the worksheet printed off, you can have a go at the questions, see what you get, see if you can sort of apply any of these little calculator methods to answering them. And then obviously, I'll go over all the answers anyway, so we can have a look at all these sorts of questions. So it says here, the graph of y equals sine x for x values from -270 to +270 is shown below. And obviously that is shown on the graph there. We've got -270 all the way over to 270 over here. It says on the same axes, draw the graph of, and we've got y equals 1 minus sine x for values from -270 to +270. So that's the graph we're going to have to draw there, and that doesn't look very nice. Now this is all sort of, this question here is very much linked into graph transformations. We're actually transforming this graph, and we just need to figure out how this graph is transformed, but actually we can actually do this on a calculator. Now this particular graph transformation here has got 2 different transformations going on, and we could rearrange that. We don't have to write 1 minus sine x, we could write negative sine x plus 1, and just sort of rearrange those if we wanted to. So we could do it like this, we could write minus sine x plus 1. Oh, missed my bracket there, let's put that back in. There we go, plus 1. And think about what these transformations actually represent. So that negative in front of the sine x flips the y coordinates from being positive to being negative. Obviously check out my video, and in fact I'll link that in the description below on graph transformations as well, because it's probably worth checking out because it does link very strongly into these trigonometric graphs. So that negative there relates to a flip or a change of the symbols in front of the y coordinates. We've then got the plus 1 at the end, and again that's outside the bracket. It changes the y coordinate, it changes the y-intercept, it moves the whole graph up by 1. So you could actually take a graph transformation approach to this. You could try flipping it over and then shifting it up 1, and we could probably do that quite nice and quick. I'm going to do it in 2 different ways though, but just if you are quite keen on your graph transformations, you could first flip it over and just think about that by flip. Oh, that's not my pen, let's just change that. We could take all of these little coordinates here, this one, this one, this one, and this one. I've not bothered with the zeros because they'll stay where they are. And we could just flip them down, change the coordinates there, and that would move the coordinates here. And we actually end up with, and I'll try and draw it. There we go, we end up with that. And then we need to shift it all up by 1. So take all those coordinates, shift them all at 1. That would shift it at 1, that would shift it at 1. Let's have a look, these 0 coordinates need shifting at 1 as well. I'll try and shift them all at 1, it's not the nicest now when you start drawing all over this. There we go, shift that all at 1. And it makes this sort of curve here. There we go, so drawing it using a graph transformation approach, let's just get rid of that red one. There we go, that is where our curve ends up following this graph transformation. Okay, not the nicest though, that's quite nasty actually. It's a very sort of horribly difficult graph transformation question, having to sort of flip it over the x-axis there and then actually shift it at 1 as well. But I'm going to take a little bit of a different approach, but just so you know, you could actually take that approach there using graph transformations. So obviously check that video out if you're not sure on that. You can always have a think about what I've actually done there once you've had a look at that. Now instead of doing that, I'm just going to take this nice calculator approach, because this was actually a calculator question as well. So rather than doing that, I'm just going to plug my numbers into this formula here. So I'm going to start with negative 270. So I'm going to do 1 take away, and I'm going to do sine minus 270. There we go. And that's going to give me my first value. So 1 take away sine, and I'll put minus 270 in the bracket, and I get the value of 0. There we go, so that's my 0. Then I'm just going to change that for the negative 180. So I'm just going to put minus 180. I'm just going back into my calculator and changing that value. That gives me that value there. Back in, negative 90. There we go, and that gives me 2. So negative 90 is up here at 2. I'll put 0 in, and that gives me 1. There we go, we'll put 90 in. And that gives me, sorry, I've put that in, 1 minus 90, yeah, that gives me 0, there we go. Then put 180 in, last one nearly done, and that gives me 1. Where's that gone? 1 is there, and then 270. There we go, and that gives me 2. And that is there. And again, just drawing that up with a nice smooth curve. Best you can. There we go. And there is our transformed graph. But again, 2 different methods that you could take to approach that. Obviously, if you're really good with your graph transformations, you could have flipped it over first, changed the y coordinates, made them positive, negative, and the negative one's positive. And then obviously shifting it up 1, doing that transformation with the 1 at the end, changing the y-intercept. Or you could just take this approach, just plug in the numbers into the calculator, plot them all nice and neat, and connect them all up together. So it's up to you which one you prefer, but just a couple of different ways that you can actually approach that question. Right, let's have a look at our next one. Okay, so this question says the diagram shows part of a sketch of the curve y equals sine x. Write down the coordinates of the point P and Q. Now obviously if you know the graph well, obviously we know it fluctuates between 1 and minus 1, so we only have to figure out the there we go, put that in. We only have to figure out the x coordinates, okay? We know the y coordinates are going to be in between these. Now these are quite nice ones. They're not shifted in between the curves there, so we don't have to think about any of these exact values or any of those sort of root 3 over 2s or anything like that. We just have to think about the nice ones here, which is sort of on the axes right there, which is quite a nice one. And this one just here. So we've only got 2 to find. Now this one here, and again, there's a couple of different ways that you could take to approach this. Hopefully you remember it. It went up in 30s. The peak there of that sort of like hilly shape, this bit here, this little peak, is at 90. Then it goes to 180, and it just keeps going up in 90s. Then it goes to 270, and it finishes up over here on 360. There we go. So we know that the coordinate there is going to be 180. So that is going to be 180 for our x value, and 0 for our y value, as it's on the x-axis there. So that's our first coordinate. Our next one down here, okay, as you can see above, is 270. There we go. And our y coordinate, obviously it fluctuates between 1 and minus 1, so our y coordinate is negative 1. Right, there we go. Is there another method that we could approach to take this? There is a little bit of a way that we could think about this. Whether it's easier than that or not, I think it's probably the easiest way there is just obviously just recognising that it goes up in the 90s. Obviously when we plotted it, we split it up a bit more. We did 30, 60, 90, 120, 150, 180 and split it up a little bit more. But I think obviously just knowing those peaks that are at every 90 Sort of does make this a lot easier there. Now, what could we do to take a different approach here? I'm just trying to think whether this is going to be easier or not. We could think about the inverse functions potentially, but it's not very nice. It does actually sort of make a bit of a mess. So for this one here, just so you do have a little bit of a different way of thinking about this, sometimes you could do sine minus 1 of 0, which is obviously what the y coordinate there is, and see what the x coordinate comes out as. Now on a calculator, unfortunately, that is going to give you the 0 there. It gives us this coordinate over here, the other position, or the smallest position there, where it actually has a value of 0. But obviously, as I mentioned, those values are supplementary, so we have two of them. We have sine 0 that equals 0, and these two angles that add up to 180. We've also got sine 180 that equals 0, and there are more beyond that, but that's obviously, I'm not too sure whether that is actually easier or not. I think the easiest way for this question here is actually just knowing that those values there, or the peaks of those parts of the curve, go through the 90s. You've got the 90, the 180, the 270, the 360, and I think that's probably the easiest way to go about this. Although you could take this other approach. I personally don't think it's any easier. I think you're probably best sticking with knowing those x values along the lines there. But there we go. That is a sort of a couple of ways to have a think about that question. Let's have a look at our next one. Okay, so a very similar question to what we had on the previous one, except this is our cos graph, and again it says write down the coordinates of point C. So we've got our point C down here at the bottom of our little curve there, and a few things that we already know. We know it fluctuates between 1 and -1, so we know that that's 1, and we know that that one there is -1. So again, we could have a think about how we could approach this sort of question, okay, with our cos graph, and think about how we might actually get to our answer here. Now again, we know it goes up in 90s, but obviously this cos graph is not in the origin, so our 90 actually hits it there at that point now, rather than in the centre or the sort of peak of that curve there. Our 90 is here, and then our next one is 180, then we've got 270 here, and 360 at the end, just like before. And there we go. And as soon as we put those values in, that sort of coordinate there seems very, very simple. Okay, so our x coordinate there is 180, and our y coordinate is -1. Okay, and that's our answer. Okay, quite nice and simple, just finding that one there. You could actually take the approach that I said before. This one's quite a nice one. It doesn't always work out perfectly the way you want it, but actually for this coordinate here, if we do cos -1, there we go, of the -1 there. This does all determine whether you know the y coordinate, but if you do cos -1 of -1, you get the answer 180, okay, basically saying what's the x value when we get a y value of -1, okay, doing that inverse of cos. So you can actually take that approach for that one. It does work for the cos graph here, give us that answer straight away, but if that method doesn't work, you are just going to want to label the axes there and just sort of read it off the graph and take that approach instead. But there we go. Obviously, as long as you know the axes, those sorts of questions are quite nice and easy, but it does obviously depend on you knowing the axes and recognising sort of those positions on the graph there. But let's have a look at something else. Okay, so this says here is the graph of y equals cos x between the values -180 and 180, and again we can see that on the graph it does stretch from -180 to 180. It says on the grid sketch the graph of y equals -2 cos x, but again between these values. Okay, so taking a little approach to this then. I'm just going to take the calculator approach. Now again, you could take a graph transformation approach to this, but let's have a look at the end and see what that graph transformation is. We'll take that calculator method to start with and just start plugging the values into this formula. So we've got y equals -2 cos x. So on my calculator, I'm just going to type in -2 cos, and I'm going to start with that first value on the x there, which is -180. So -2 cos, and then -180 in the bracket, and it gives me the value of 2. There we go, that equals 2, and I'm just going to do that same approach for all of them. So that 2 goes up to there, and there we go. So back into the calculator. I'm not going to sort of do all the little sub values in between. I'm just going to go straight for -90 and see where that is. So -90 ends up at 0. There we go, so that stays where it is. I'm going to go for 0 now, so back in, -2 cos 0, and that gives me a value of -2. And let's go back for 90, -2 cos 90, gives me a value of 0, and -2 cos 180 gives me a value of 2. There we go, so that value of 2 is there. And again, we just need to join that up with a nice smooth curve. There we go. And that's our point drawn there. So again, that's one method that you could approach. If I swap to a different colour here, we'll have a think about the graph transformation as well. So negative there flips the coordinates over. So I could have actually started by flipping those coordinates over. So let's go about doing that. We've got this one here, which is going to flip to the other side there. 0, that one there stays where it is. This one here on 1 flips down to -1, which I can just about see. It's about there somewhere. We've got the one on the axes then, which stays where it is. And we've got this one down here, which flips up above. So the minus part, okay, just like before, changes the symbols in front of the y coordinates. So we can draw that in. Okay, I'm going to get rid of this in a sec. And just about draw that in, there we go. So that's what the negative part does, and then you've got the 2 there, and again this is all linked to graph transformations, but the 2 is going to double the y coordinates, okay, outside the bracket, not affecting x, it affects the y coordinate, does what we expect, 2 multiplies the y coordinates by 2. So this coordinate here, that's currently at 1, goes up to 2, which is there. 0 stays as it is. This one here, which is at -1, goes down to the -2, which we've got here on our actual graph. Again, 0 stays where it is on the next one, and then again finishing it off with this one, that 1 there goes up to the 2. So you could actually take a graph transformation approach again. Again, I think it is actually a bit harder than just type it in on the calculator, but just so you know that there are multiple methods that you could use here. There isn't just one way to solve these sorts of questions. But there we go, that is our final answer there with our nice green line that we've drawn in. I think just taking a calculator approach was a lot easier, but obviously if this was a non-calculator question, and this was actually a calculator question, but if it was non-calculator, you would have to know those graph transformations there, but this would be a particularly nasty question if it was a non-calculator one. Right, okay, so let's have a look at our next one. Right, so well done for getting this far. This is our last question of the video that we're going to have a look at, and let's see what it's all about. It says, here is the graph of y equals sine x plus a plus b, given that A is between 0 and 360. Find the values of a and the values of b. Now this is a particularly nasty question actually, because there are 2 graph transformations going on here, and we need to figure out what's actually happened. So you definitely need to use a graph transformation approach for this, although I'll have a little think and think if we could take this in a different way. But let's think about our graph transformation. Now this is the graph of sine. Obviously the sine graph is being changed, but we could actually think about drawing our sine graph in. Now sine obviously starts in the origin, and then it fluctuates and it goes between these values here. I'm going to draw it in. I'm not going to draw it in perfectly, but there we go. It fluctuates between these. And there we go, and we should recognise that sine graph now. So if I join that up with a nice smooth curve, and let's just have a little look at what this graph looks like, and have a think about what's actually happened to this particular graph here. Now, if we have a look, this part of the graph, it's almost like it's shifted down this way. Okay, it's kind of shifted down to there. Okay, all of these points are sort of shifting downwards. This one up here is shifted down to there, and it's sort of moved in this sort of strange direction. So we're going to have a look at how we actually get this graph to get to that position. Now, this peak here, this one here is the one I'm looking at, it's shifted along 2 spaces to the left, look, or 2 little squares to the left, because that peak is now sitting there. Okay, it has also moved downwards, but just in terms of that left-right movement, that peak has moved to the left. Now we know that it's that peak as well because it says that that value of a is somewhere between 0 and 360. Obviously this graph here, if I had obviously an extension and this line went all the way, I don't know, to a certain amount of degrees, we would be able to see that this sort of line continues like that forever. Okay, but this says it's between 0 and 360, so we're only looking at this particular part of the curve and how much it's shifted along. So we know it must be that peak there, as our next peak would be somewhere, you know, over here, and that's definitely not shifted all the way down to there because that's way over 360 in terms of the movement. So actually let's have a look. How do we get this graph to move to the left and down? Now in order to get it from where it is at the moment, and it's sitting on 90, we want to move it left by 90 degrees. So in order to move the graph left by 90 degrees, we do need to know graph transformations here. We want that to move in the x direction, so it is the number that affects x, and we want it to move to the left. Now when it comes to graph transformations here, that number that's inside the bracket always does the opposite of what we'd expect. So to move left by 90, we need that to be positive 90 there. So we would have to have sine in the brackets x plus 90. and that moves it left by 90. And then we want to figure out what B is. So obviously that point there, and as you can see how that point's moved. Let's just get a different colour. It's also moved downwards. So once it's moved to the left there, it also has to move down. Okay, from 1 down to 0. So that is obviously a change in the y-intercept, because the y-intercept would be +1 if we moved it along, and we want it to move down to the 0. So we want it to go downwards. Now, we don't have to think about the opposites when it's outside the bracket, but that value of B will have to be -1 to allow us to move that graph downwards. So our value of A is the 90 there. That allows us to move it left by 90. And our value of B there is -1. And that allows us to move it down 1. So that's our two values. That's how we would get our graph to move. Obviously that did depend on us being able to draw a nice little sketch of the sine graph there. And again, you wouldn't even have to think about that if you had a calculator, because you could just plot all those points using the x values and actually getting your graph drawn in and just thinking about how it moves there in terms of making sure that that peak moves to a different position. Of course, you didn't have to use the one that I was looking at. You could have looked at this bottom of the peak there and thought of how we got that to there. So it goes left from 270 to 180, which is a move of 90, and then it goes down from -1 to -2, which is a movement of 1 down. So again, you could have looked at that part of the graph as well, but I just decided to pick the one that I looked at to start with, okay? But different ways that you could look at it and sort of find those movements, and sort of obviously that did require you to know your graph transformations quite well, so do check that out in the description if you haven't already, as well as obviously the exact values of trig that's part of this trigonometry series, okay? But there we go, that's the end of the video. If that was helpful, if it was useful, please like, please comment, please subscribe, and I'll see you for the next one.